So in this lecture, we are learning the logistic regressions formulations. So if you just remember, in the series of logistic regressions, we have already learned how to formulate the logistic regression equations. Okay, so I am now just revisit this concept by using the Lagrangian multipliers to a constant optimization problem. So let's start. How to formulate this logistic regressions problem by using constant optimization. Okay, so first write down what is our logistic regressions optimization problem. So in the end of the day, we find the optimal W, that is called W star. This is equals to arc mean of our all over W, that is our logistic loss, plus some regularizer. So let's take, we have our L2 regularizer. This is our regularizer. This is our riser. Okay, and this is just simple. If you just remember in previous lecture, the Lagrangian multiplier, this is like of, this is one kind of like of Lagrangian multiplier. This is one kind like of Lagrangian. This lambda is one like of Lagrangian multiplier. This portion. Lagrange multiplier. So just think the logistic regression problem geometrically, then it will be clear. So first, what is our actual geometrical problem? What is actually W? W means nothing. It is the normal. It is the optimization. If we have the data set, suppose let's one kind of data set is this, and let another kind of data set is this, and if we have this is our optimal plane, then W is what? W is nothing. This is the normal to our plane. W is our normal to our plane. Let's see, this is our simple W. So and W star is nothing, is the normal to our optimal plane. If our optimal plane is pi, then W star is the normal to this optimal plane. So simply just write down it in geometrically. Simply geometrically concept. Just revisiting geometrically. Geometrical interpretation. In geometrical interpretations, we find the optimal W, that is our arc mean of W. Simply here we are using simply like logistic loss functions. Loss function in geometrical interpretation. This is simply the logistic loss functions, and this W is the normal to the plane. So since it is the normal to the plane, here we are in just simple the formula of normal vector. So in for normal vector, W transpose W will be 1. Okay, this will be the 1 for a normal vector, just using this concept. Just if you compare these equations and these equations is simply this equation simply a objective function. Just if you remember the multiple constant optimization problem, this is like a optimization function, objective function. This is like a objective function, and this is like a equal constant, equally constant. This is like a equal constant. So simple, the logistic functions can be interpreted as multiple constant function, constant optimization problem like this. Okay, here in logistic regression we see that these equations is our regularizer form, and simple these equations is and geometrical. If you just think the geometrical interpretations, from geometrical interpretation perspective, these equations is coming as a constant optimization problem. So now if you just apply here Lagrangian multiplier, just here we are applying the Lagrangian multiplier. So our Lagrangian, after applying the, here is simple, we are Lagrangian multiplier, playing the Lagrangian multiplier here. L, just I am writing, after writing this equation, L of this is equals to our objective functions, means what? Our objective function is our simply logistic loss function, plus here I am using this, I am using some both sums of minus, will be minus some parameter lambda into W transpose W minus 1. Okay, both are the same thing. If you interested to use 1 minus this, these both are the same thing, so it is not make a problem. I think this is okay. So just simple to compare these equations, I am not here using this term, I am just using here this term. I'm here simply using here this term, 1 minus W, using 1 minus W transpose. If you are interested, then you can use it, no problem. Just I'm comparing this equation with this, then so this equations is the functions of W and lambda, okay. So simply what will be our main equation? This is our logistic loss minus lambda plus lambda into W transpose W. Okay, simply this equation is converted. Just if you omit this constant term, if you just omit this constant term for a while, if you just omit this constant term for a while, then you simply compare these equations, this term and this term. If you just compare these two things, you just compare the two things, then simple it is our regularizer. Just if you compare this is our simply a regularizer term, and this is our simply a logistic loss function. This one is the logistic loss, and this is our regularizer term. Just compare these equations and this equation, both are the same thing, both are the same kind of equations. This is our simply using the regularizer concept, and this equation simply is coming from our Lagrangian multiplier concept, but both are the adopted in the same kind of formula. So equation coming from income rate. So regularizations can be thought. So regularization can be thought as a imposing equation. That is considered here. Regularizer can be thought as a imposing equation that is considered here. Okay, I think both the concept are similar kind, but the interpretation is different. So this is the main beauty. This is the most beauty thing, the mathematics. Yep. So we can interpret it this thing differently, but the concept is same, but the interpretation is different. Okay. So this is the another interpretation. This is the another interpretation, the regularizer. This is the another interpretation of the regularizer. So this is another interpretation of the regularizer. So this is the one interpretation. Regularizer, that the concept of regularizer have many interpretations. But one of them is simply the equal optimization constant equations and Lagrangian multiplier. I think the beauty of this logistic regressions, you are simply understand how the geometric interpretations and the Lagrangian multiplier interpretations both are combining to a both are the combining through a regularizer term. Okay, I think this concept is clear all of you. So this is the main beauty. Okay, and there have also as we progress this series of lectures, then you can see how the regularizer, how the multiple interpretations of the regularizer can we learn. Okay.